establishing relationship between say, southern oscillation, which is nowadays called as El Nino and southern oscillation, and the Indian monsoon. And as we move towards El Nino condition this year, you can just imagine at that time, India came up with the discovery of the El Nino and southern oscillation.
1923.
1923. And based on that, the long-range forecast of monsoon was taken off.
So this year, what is the condition?
So this year, at present, it is the neutral condition. And as per IMD's forecast, we are moving towards an El Nino condition towards middle of the monsoon season, maybe in the month of July. So if there is large snow cover or snow cover area is more, then this monsoon circulation becomes weaker. And hence, the seasonal rainfall is inversely related. That means if your snow cover area during December, January, February, March is more, rainfall in monsoon season June to September will be less. At present, it is a neutral Indian Ocean Dipole, and we are expecting that towards second half of the monsoon season, there will be development of the positive Indian Ocean Dipole.
So that means there are two factors that can mitigate the El Nino.
That can mitigate to some extent.
So we should breathe a sigh of relief.
May not be able to completely neutralize the adverse impact, and hence we are expecting that there will be below normal rainfall for the country as a whole during this monsoon season 2026. And also in many parts of the country there will be below normal rainfall, except Northeast India, where we are expecting above normal rainfall. Similarly, Godavari and Krishna basin area covering Telangana, South Chhattisgarh, South Odisha, North Andhra Pradesh, that also expected to get normal to above normal rainfall.
Today we are joined by Dr. Mritunjay Mohapatra, a famous man in the world of earth sciences and a very famous man in the world of meteorology, not just in India but overseas as well. He started his career as he was academics. He went to physics, and then he started his career with DRDO, then became a lecturer for some time, and then finally joined IMD and spent several years in the IMD, several decades. He's been Director General of IMD for about 6 years. This is the 7th year running. His services to the country have been outstanding. In my time at NDMA, I got to meet this gentleman, and what a fine scientist he is. And he introduced me to many more excellent scientists like him in IMD. And the image of the Indian scientist slowly, quietly, noiselessly working in Indian scientific establishments. This is what we will see in the next several minutes when we talk to him. He was honored with the Sasakawa Award, which is an international award, and it is a very rare award given to very few people. So if you Google it, you will find how important it is. One of the few Indians to have been given that award. So welcome, Dr. Mohapatra. Thank you for joining this podcast. And we will just go through a few questions. And are there any opening words you'd like to make?
Yeah, thank you very much, Raju Saf, for giving this opportunity to speak to you. With your dynamic leadership, there has been significant improvement in disaster risk reduction in the country. And IMD is the early warning service provider enabling the disaster risk reduction. So therefore, I feel privileged to talk to you on this occasion.
Thank you, sir. Thank you so much for coming by. So we'll start with what is IMD, how big is IMD? We only hear about IMD when it rains or when it's very hot. So please tell us something about maybe the origins of IMD, how large it is, where it is spread.
IMD is the India Meteorological Department, which came into existence in 1875 following the massive floods and droughts and tropical cyclones devastating the country at that time. And over the period, it has transformed itself depending upon the demand of the society and also the supply chain. As in the beginning it was facing the disasters, it started as an organization to deal with the natural hazards. And therefore, if you look at the first weather forecasting services came into the country in the form of the port warning in Calcutta port in 1865, even prior to the existence of Indian Meteorological Department. However, because of the continuous effort of the Asiatic Society of Bengal, the IMD came to existence in British India, and the first and foremost problem, if you look at the country, is the monsoon. So therefore, the first attention was taken up to address the requirement of the monsoon forecasting, just like we see in our Vedic era or with the ancient era. Even Chanakya has told about the importance of rain gauge and rainfall measurement for agrarian economy. So towards this direction, the effort was made to predict monsoon. Even in 1878, the first long-range forecast of monsoon was given by India Meteorological Department, considering the relationship between Himalayan snow cover and the seasonal rainfall during monsoon season. If snow cover is less, expected monsoon is better, and vice versa. But however, over the period, then people thought that it is not the only factor because monsoon is a large-scale phenomenon. So in 1923, we came up with establishing relationship between say, southern oscillation, which is nowadays called as El Niño and southern oscillation, and the Indian monsoon. And as we move towards El Niño condition this year, you can just imagine at that time, India came up with the discovery of the El Niño and southern oscillation.
1923.
1923. And based on that, the long-range forecast of monsoon was taken off. And however, as the science grew, people could find that it's not the only two parameters. There are many other parameters across the globe.
Let me stop you there. Can you quickly explain El Niño? What is El Niño? How does it form?
Yeah, El Niño is a condition of the sea surface over the equatorial Pacific Ocean. Usually, the Pacific Ocean is the warmest ocean in the globe, and within Pacific, Western Pacific Ocean is the warmest. And if you look at the temperature difference, the East Equatorial Pacific is relatively colder and West Equatorial Pacific is relatively warmer. But this difference in warming and cold conditions in the two ends of the Equatorial Pacific does not remain same always. Under certain circumstances, the temperature near the Western Equatorial Pacific may rise and near Eastern Equatorial Pacific may fall. In such situation, the cloud formation or the upward motion of the atmosphere will increase near Western Equatorial Pacific and it will be suppressed near Eastern Equatorial Pacific. So this type of condition is called as La Nina.
Oh, so very simple that if the eastern side temperatures are lower, the water is cooler,
Yes.
and the western is slightly warmer, so there will be more clouds this side and less this side.
Yeah.
This side. So it's La Nina.
La Nina.
So it will be slightly
In
colder
the
on our
opposite,
side.
of course.
Opposite.
That means temperature is lower in Western Equatorial Pacific and higher in Eastern Equatorial Pacific. Then severe weather occurs over Eastern Equatorial Pacific like South America, Argentina, Brazil, Chile, Peru. They experience very intense thunderstorm activities and there are lots of people. And also, above all, the livelihood is also affected. Like with the rise in sea surface temperature near Equatorial Pacific, the fish community, they move away from the coast. Therefore, the fish catch of the fishermen decreases. So, therefore, they pray God that this year it should not be the El Niño. El Niño means the birth of a little boy child, and La Nina means little girl child.
Okay.
And
The boy child is the bad boy and the girl child is the nice person.
Yes, and usually this phenomena of El Niño starts towards the end of December. That is the birthday of Jesus Christ, 25th December. So they will be praying to Jesus Christ that this year, or the ensuing year, should not be an El Niño year. So what I want to say is that the El Niño or La Nina conditions affect not only this East Equatorial Pacific or West Equatorial Pacific, but it affects the entire globe.
So this year, what is the condition?
So this year at present it is a neutral condition, and as per IMD's forecast we are moving towards an El Niño condition towards middle of the monsoon season, maybe in the month of July. But while telling so, I want to say that about 60 to 70% of such years with El Niño are badly affected by the reduced rainfall activity. But there are still around 30% of years when there is El Niño, still we get good rainfall activity. That means there is no such one-to-one relationship between monsoon season rainfall and El Niño.
So what is it that mitigates the effect of the El Niño?
Yeah, there are various effects. One of the most important effect is Himalayan Eurasian snow cover. So if the snow cover is more, then the land surface becomes colder. And in such a situation, what happens actually, the sea surface is colder. So temperature gradient between sea and land decreases. And you can assume just like monsoon is a giant sea breeze. So if there is large snow cover or snow cover area is more, then this monsoon circulation becomes weaker. And hence the seasonal rainfall is inversely related. That means if your snow cover area during December, January, February, March is more, rainfall in monsoon season June to September will be less. If snow cover is less, rainfall will be more. And this year, during December, January, February, March, snow cover area has been less than normal. So therefore, the adverse impact of El Nino will be countered
To some extent.
to some extent by the
Which are the other factors?
yeah. So there is another circulation, you can say, over the Indian Ocean, which is called as the Indian Ocean Dipole. Just like the seesaw phenomena I explained you in the Pacific Ocean, like sea surface temperature in West Pacific it is increasing when East Pacific decreasing. West Pacific decreasing when East Pacific is increasing. And this phenomenon is also seen in the equatorial Indian Ocean. The West equatorial Indian Ocean near Somalia coast, usually it is warmer, and East equatorial Indian Ocean near Indonesia is cooler. If near Somalia it becomes more warm, and near Indonesia it becomes less, that means less warm, it is called the positive Indian Ocean dipole. And by that way, as we know, monsoon, southwest monsoon is a cross equatorial flow. It flows from southern hemisphere, that is South Indian Ocean, towards
It's the trade winds.
the Arabian. It's a trend wind. So if Somalia coast, nearby Somalia coast, West equatorial Indian Ocean is becoming warmer, the trend wind becomes stronger. So that means positive Indian Ocean dipole is good for Indian monsoon.
So how does it look this year?
Yeah. The opposite is the negative Indian Ocean. At present, it is a neutral Indian Ocean dipole, and we are expecting that towards second half of the monsoon season, there will be development of the positive Indian Ocean dipole.
So that means there are two factors that can mitigate the El Nino.
That can mitigate to some extent.
So we should breathe a sigh of relief.
Yeah, but still, the prediction, what you talk about El Nino, it is expected there will be some accelerated increase in temperature.
Okay.
Therefore, the combined impact of this positive Indian Ocean dipole and the Himalayan snow cover or other factors may not be able to completely neutralize the adverse impact, and hence we are expecting that there will be below normal rainfall for the country as a whole during this monsoon season 2026, and also in many parts of the country there will be below normal rainfall except Northeast India, where we are expecting above normal rainfall.
Okay.
Similarly, Godavari and Krishna basin area covering Telangana, South Chhattisgarh, South Odisha, North Andhra Pradesh, that also expected to get normal to above normal rainfall.
Okay.
So, therefore, even if it is a large scale below normal rainfall, we should prepare for the drought like situation or deficient rainfall management with complete monitoring of the available water and reservoirs, etc. We should also take care of the floods. During the below normal monsoon years, usually Northeast India gets very severe floods. So that we should
In a
also
below
be prepared.
normal monsoon, Northeast India gets severe floods.
Yes.
What is the link?
Because all India monsoon becomes good when, so for example, different components of monsoon, characteristics of monsoon is such that monsoon flow is stronger, and monsoon trough, which roughly runs from Ganganagar to Allahabad to Kolkata, that lies in normal position or to the south of that. But when monsoon becomes weaker, this monsoon trough shifts towards the foothills of the Himalayas. So therefore, wherever is the monsoon trough, there will be more convergence of wind, and hence the northeastern states, northern parts of say UP, Bihar, Nepal, Bhutan, and say Ladakh, adjoining areas of Jammu and Kashmir, northern parts of Himachal Pradesh and Uttarakhand, they will get more rainfall activity.
Okay, so that is the general prediction. This is
Yes.
what IMD is for, and that's an extremely
Yes.
good way of explaining it. There is also something which you told me once about the Tibetan anticyclone. What is that?
Yeah, monsoon is a large scale phenomena, circulation. It is a global circulation. It extends from America to, you can say, entire Asia and up to the eastern coast of Africa. So, over the different regions of the globe, monsoon has different characteristics. So, South Asian monsoon, which prevails in our area, it has, apart from this large-scale phenomena I told you, like El Nino, La Nina, or Indian Ocean Dipole, or Himalayan snow cover, Eurasian snow cover, it has got some regional features. One of the regional features is the monsoon trough. Other one is a heat low over Pakistan. If heat low is very intense, then monsoon becomes good. If heat low is weaker, monsoon becomes weaker. Then similarly, we have got the tropical easterly jet passing through Trivandrum and Chennai latitude at a height of about 10 to 12 kilometers. Their wind speed becomes about 150 to 200 kilometers per hour at a height of 12 kilometers.
Okay.
Similarly, we have got the Somali jet. In the lower level, at a height of 1.5 kilometers from the sea surface, wind will be around 70 to 80 kilometers per hour.
1.5 kilometers below the sea surface?
No, above.
Okay.
Similarly, in the Tibet, at a height of about 10 to 12 kilometers, there will be a high pressure area. And this high pressure area arises because of the intense heating during the summer season. And therefore, it is a dry anticyclonic circulation or Tibetan anticyclone. And if this Tibetan anticyclone is stronger, then monsoon becomes stronger. Not only the monsoon activity, but also the onset phase of monsoon. If Tibetan high is stronger, the monsoon comes early, monsoon becomes good in time. So, Tibetan high provides the upper level divergence, which will induce the lower level convergence over the Indian region, and hence monsoon to become stronger.
Excellent. Very well explained, and we'll also have to go through this 3-4 times to absorb it completely. So, two more points that seem to be affecting.
But I'll just tell you one more point here.
Please.
Apart from this Tibetan anticyclone, heat low, monsoon trough, and then I told you low level jet near Somalia, tropical easterly jet, there is another phenomena which is called mascarene high. It is a high pressure area over the Mascarene Islands in South Indian Ocean. There is another high pressure area over the Australian high. These two high pressure areas provide the current, monsoon current, which comes as a trade wind. If these two high pressure areas become stronger, then monsoon becomes stronger. If they become weaker, then monsoon becomes weaker. So, while El Nino or La Nina, Indian Ocean Dipole, or the phenomena like Himalayan snow cover decide the total annual behavior of monsoon, within the monsoon season itself, there will be large-scale variation from day to day rainfall activity. That is governed by all these factors.
Amazing. That's really amazing. So, is there any effect of the typhoons in the South China Sea on our side?
Yes. During monsoon season, we get about 87 centimeter rainfall over the country as a whole. If you look at the monsoonal low pressure systems, contribute about 30% of rainfall of the country. So, if there is no low pressure system, you will face drought. If there is a low pressure system consecutively again and again, you will get the floods. About 13 to 14 low pressure systems developed during the period of 1st June to 30th September. And most of them develop over the Bay of Bengal, that is our North Bay of Bengal, of say Odisha, West Bengal, or North Andhra Pradesh coast. And mostly they move over North Odisha, West Bengal, and towards Gujarat and Rajasthan across Madhya Pradesh and Chhattisgarh. So, usually they will have the life period of 5 days. Okay. So, in a season of 122 days, low pressure systems develop for about 57 days. And these low pressure systems therefore decide the activity and distribution of say dry spells or wet spells, floods or deficient rainfall in the country. Out of these systems, 14 systems, 5 to 6 becomes the depressions. And very rarely 1 or 2 may become cyclones. That is again within the month of June and September. That is the onset phase of monsoon and withdrawal phase of monsoon, they develop. But most important thing is that these low pressure systems originate as a remnant from the tropical storms and depressions which develop over the South China Sea. Because of the rotation of the earth, the storms and depressions move nearly northwestwards or west-northwestwards. There is a force called Coriolis force. It governs that type of motion.
Coriolis force. I remember my geography book from last night.
Yes. Okay. So, the system which is developed over South China Sea they will move towards Southeast Asia, like Thailand, Myanmar, Vietnam, etc. But if you look at the surface area of the Southeast Asia, it is very small area. Therefore, while they move across Southeast Asia, they do not dissipate completely, and rather they will evolve over the Andaman Sea and adjoining eastern part of the Bay of Bengal. And again, they will move towards northwest, and hence they will become low pressure systems.
So they contribute to the low pressure systems, or they become the low pressure systems?
About 70% of the systems which develop over Bay of Bengal, they come as the remnant from the Northwest Pacific.
Okay, that's a great contribution of the South China Sea to the Indian side.
Yes.
Okay, so the one last thing that makes a difference is the western disturbance. So can you please explain how it rises, where does it come from, and what impact does it do on when it meets the monsoon?
As the name suggests, western disturbance, it develops in the westerly winds. It develops over the Caspian Sea, Red Sea and Mediterranean Sea area, and they move eastwards across Africa, across Iran, then Pakistan, Afghanistan, then come to northwest India. And these western disturbance frequency is maximum in the winter months, like December and January. About 7 western disturbances affect India in the month of December and January.
On average, 7 of them.
On the average 7 each month.
This is what brings winter rain to northwest India.
This brings the winter rain. So western disturbances, as name suggests, they develop in the west over Mediterranean Sea, Caspian Sea, Red Sea area, and they develop in the westerly winds. And they move from west to east across Iran, Afghanistan, Pakistan, then northwest India. Over northwest India, they usually move east-northeastwards. And the frequency of these western disturbances are maximum in the winter months like December, January and February. About 7 western disturbances normally develop in the month of December and January. But it does not mean that other months also does not experience western disturbances. Yes, it experiences western disturbances, but they do not usually affect the Indian region. If you look at the signs of western disturbances, their origin is different from, say, convective systems like, say, tropical cyclones, depressions, low pressure area. While these are the convective systems, they are the tropical systems, western disturbances are the extratropical systems, mid-latitude systems. While the tropical systems depend upon the intense heating and convective process and availability of moisture in the atmosphere, especially in the sea areas, the western disturbance depends upon the temperature gradient. North-south temperature gradient, if it is high, then it can lead to development of the western disturbances. And in the winter months, as all of us know, so there is a high temperature gradient in the north-south or northwest India. So, for example, if I take Delhi to Moscow, temperature gradient will be quite high. So, higher the temperature gradient, more intense will be the western disturbances. So, when they come in the month of January or December, February, they are more intense and they travel also towards southern latitude, and sometimes the western disturbance can penetrate up to even central parts of the country. So therefore, sometimes with the western disturbance we get rainfall even up to northern parts of peninsula, central India, eastern India, northeast India, and apart from the northwest India. It causes very intense snowfall activity, leading to disastrous situations also in western Himalayan region. When you come to the summer, because of the heating, the western disturbances, though develop, they do not come towards the Indian region, they shift towards the north. And the factor which determines their path is the say Rossby waves, the waves which travel from west to east, high wavelength waves. And
what
the characteristics.
What are they called?
Rossby waves.
ROS?
ROSSBY.
ROSSBY.
Okay. So they move from west to east, they're large amplitude waves. With the amplitude waves, these western disturbances get developed and their intensity increases. Now, as I told you, the temperature is the main criteria here, temperature gradient. So if the temperature to the north increases, then the temperature gradient between, say, northwest India and, say, North Pole or, say, Moscow latitude will decrease. Then western disturbance will be weaker. Because of this impact of the climate change, what is happening now? There is warming, and the rate of warming is more if you go towards the pole. Say, for example, Arctic warming. So, because of this Arctic warming, the western disturbances, which were earlier affecting Indian region, they are moving towards northern latitude. So, therefore, the frequency of western disturbances, which is affecting India, that is becoming less. And further, as it moves towards further northern latitude, whatever rainfall we get with western disturbance, that is also decreasing. So, winter rain, if you just look at winter precipitation, that is decreasing over western Himalayan region because of the direct impact of those relative northward shifting of western disturbances, and indirectly you can say because of the Arctic warming. So as the trend goes on, as the temperature is still going on increasing, and this trend is expected to continue.
Okay, that's disturbing.
Yeah.
When in the last few years, I have heard that when the western disturbances come during the monsoon, they can cause severe havoc. Have there been any such examples?
Yeah, certainly. If you remember even 2013 Kedarnath episode, so that was the case when monsoon was in active phase. So when monsoon is in active phase, you will get some kind of low pressure systems embedded in the monsoonal circulations, and you will have strong easterly winds coming from Bay of Bengal, which will feed moisture towards northwest India and western Himalayan region. At the same time, if you have an approaching western disturbances, which brings the westerly winds, which is dry winds relatively, there will be a combination of two types of air masses. In the lower level, you have got very warm and moist air. In the upper level, western disturbance is upper air system. It usually appears at a height of say 5 kilometer to say 10 kilometer. So therefore, in the upper level, you have got dry and cold wind. In the lower level, you have got warm and moist wind. So this type of combination of winds over northwest India, especially western Himalayan region, if there is an approaching western disturbances, leads to very intense thunderstorm activity, sometimes leading to very copious amount of rainfall, which we popularly call as the cloud burst. So this type of interaction between the mid-latitude circulation or the western disturbances and the monsoonal circulation creates havoc sometimes, leading to very intense rainfall and hence the landslides, mudslides. And further, if it occurs in the month of July, for example, July is the most intense monsoon months, and August also. And during that month, the northwest India, that is western Himalayan region, is the hottest. July is the hottest month for the region, so Jammu and Kashmir, Himachal and Uttarakhand. So therefore, there will be melting of ice or melting of snow. So therefore, there will be additional water in the glacial lakes. So you have got a multi-hazard scenario at that time. You have got melting snow impact, you have got the enough water in the glacial lakes, and at the same time you have got the copious amount of rainfall. So this multi-hazard scenario will be combination of the heavy rainfall, then the glacial lake outburst, then melting of snow, and of course mudslides, landslides, etc.
So this is what happened in Kedarnath in 2013.
Yeah, it happened in 2013 recently also. Last year in 2025, if you just look at, there is many such episodes of the cloudburst and the mudslides, landslides. To remember, say Dharali and Uttarkashi.
Okay.
All these events occurred in the monsoon season in western Himalayan region.
Okay. And when that glacial lake outburst happened in South Lonak in Sikkim, what was the cause for that?
Yeah, similar is the case. There was a good amount of rainfall activity, and monsoon had the good impact. Therefore, the glacial lake was full of water. And whenever there is additional water, certainly there is outburst. And therefrom, you have the river Tista. So therefore, inflow increases in the river, not only with water, but also the mud. So therefore, it creates havoc in the down the line of the river, and which we have seen in case of the Sikkim floods, which impacted not only Sikkim but also the North Bengal.
Yes.
So these are very tricky situations, and because of the impact of the climate change, as the temperature is rising more as you go from south to north, so therefore northern part is getting more impacted, and the glaciers are melting. And there are studies shows that the eastern part of the Himalayas, say for example East Nepal, Bhutan, Sikkim, they are more affected as compared to the western part, like say western Himalaya, Karakoram. There the rate of melting of the glaciers is less in western part, more in eastern part.
That's why it's known as the Karakoram anomaly.
Yeah, therefore it is called as Karakoram
So
anomaly.
this is a long-term phenomenon. It's been going on for a long time.
Yeah, that is a long-term phenomena since the beginning of the industrial age in 1850. So, man-made activities or anthropogenic activities is going on, and it is contributing towards the increased concentration of the greenhouse gases like carbon dioxide, methane, etc. What is found that over the years, since 1970s, it has been accelerated. More amount of greenhouse gases you can find out, and therefore accelerated impact of the greenhouse gas. Greenhouse gas, as you understand from the glass house in certain parks and gardens, it traps the radiation emitted by the surface of the earth. It is absorbed by the water vapor, carbon dioxide, methane, etc. And hence in the lower level, the temperature of the atmosphere increases. It has increased for about 1.15 degrees Celsius globally, and in India also about 0.67 degrees Celsius in past 100 years. And if you look at past 50 to 60 years, in 1970, this is more. It is about 1 degree Celsius rise, for example, in India during 1970 to 2020. And it's this rising temperature not limited only to the land surface. In the sea surface also there is rising temperature. And all of us know that water has the capacity of holding, that is heat capacity of water is maximum, that is 1. So therefore, if sea surface temperature is increasing, also it is dangerous in the sense that the aquatic animals, including the food chain of the living beings like say fish and others, will be impacted. One more thing is that sometimes people feel happy that ocean is absorbing the carbon dioxide, it is a sink. So it is good that we have got the oceans. But if ocean goes and absorbs the carbon dioxide, it becomes more acidic. Again, it becomes detrimental for all the lives within the aquatic lives. So therefore, you cannot be complacent that we have got oceans and there is a safe place for absorbing carbon dioxide. Similarly, forest cover also there, and you have got the permafrost and wetlands. So we have to preserve the sanctity of the ecosystem so that not only they will act sink for the coming ages, but also they will support us for all ecological balances.
So what can we as human beings do to conserve our glaciers? What can we do in a very simple way?
There are two ways. One is the macro level policy. As all of us know that United Nations Framework for Climate Change Convention came in 1992 after so many protocols, etc. And now till date we have come up with the Conference of Parties. Every year we have got the meeting, and formulation of the policies and plans and programs are being taken up internationally. But if you look at nationally also, yes, many countries have taken up. India has its National Action Plan, Prime Minister's National Action Plan for Climate Change. We have got 11 missions within that, and also it has populated to states and districts. We have got state climate cells and climate action plans nowadays. So that is one way, macro level it is being dealt with to minimize the sources and maximize the sink. And there are various ways to do that. But when you come to, for example, an individual can also contribute a lot. Say for example, if we know that what is our carbon credit, how much carbon dioxide we are consuming because of our lifestyle, because of our food, because of our clothes, because of our shelter, our dresses, etc., then perhaps we can minimize our contribution. Say for example, if we are traveling by vehicles and we know that our vehicle is not electrical and the vehicle is utilizing say petrol, diesel, it is releasing the greenhouse gases. So if I stop vehicle for one day, and I can minimize my carbon contribution. Similarly, if I have to go for say 1 kilometer distance, I need not take the vehicles. Say for example, I can go for cycle, I can go by foot also. So that can help us. Similarly, the polythenes or the plastics, I can minimize the use of plastics which are not degradable and which likelihood is quite high. Third point is that we can go for plantation, tree plantation. We can avoid cutting of the trees, etc. So like this, we can have a number of steps. For example, if I am not in the house, why should I switch on the light? Why should I switch on the AC? I can minimize that. I can switch it off. I can go for automation so that when I go out, it will completely switched off. So by that way, when I, for example, if I take say 100-watt bulb, so it becomes for one day, if it is continuously running, then it becomes 2400 watts at 2.4 kilowatt. So 2.4 kilowatt means 1 kilowatt hour. You are say paying 6 rupees. So now you are paying 2.4 into 6. So it is 15 rupees. You might be thinking that I have sufficient money, 15 rupees nothing for me for a day. But you should know that government is also paying 15 rupees. It becomes total 30 rupees for 100-watt bulb to run 24 hours. And not only that, when you run the bulb, it is coming from the coal energy. And coal energy is conserved. It is destroying. And you cannot assume that coal will continue. And again, when you burn a coal is carbon. And it is burned in the presence of oxygen. It becomes carbon plus oxygen, carbon dioxide. While carbon has the atomic weight of 12 grams and oxygen has 16, now total becomes 32 plus 12, so 44 grams. So you are burning 12 grams of coal, but you are producing 44 grams of carbon dioxide. So if you understand that, if you calculate how much you are, that means whatever coal you are consuming for at least 1 watt bulb, I told you.
That's a very brilliant point that needs to go into our school textbooks.
Yes.
This little maths,
Yes.
that when you burn a bulb for one full day of 100 watts, what is the damage you cause?
Yes.
So it will make a revolution with all the school children, telling their parents to switch off electricity.
Certainly.
Very well explained.
So from micro level, we can do a lot. For example, while we are brushing our teeth, what is the bad practice is that we keep on open the tap. There is no need.
No need.
Similarly, when you go for shaving the beards, etc., also we keep on open. So like that, if we can rationalize our behavior, if you can optimize our actions, we as individual can contribute a lot towards minimizing the concentration of greenhouse gases, ensuring the ecosystem, and also will ensure for the future generations, not only for ourselves.